Subscriber, huh? Okay, welcome guys. Today I think I'm going to talk about GCC. Used it a lot, but I don't think we ever really explored GCC. So um, let's see. So let's go to man GCC. Before that, I think let's talk about GCC. So GCC, I think there's the main options that I know of is the W for warning. So this is warnings. Um, the F option is most of the options. So this is most options for GCC is the F option. GCCM is for machine options. And there's really a lot of options for GCC, so you have to look at the man page to view most of them. Okay, and then also one that I know of is G. That's for debugging and keeping the debugging symbols in there. So okay, so yeah, let's save that. Um, so let's go back out and let's do look at the manual for GCC. Oh, okay. So and we'll go through all this. So the main options they have is C. That's to compile it. S is for assembly. If you want to uh, create your program into just assembly code, you want to look at that. And there's also the E option, which is, I believe it's the preprocessor. Um, and so this is good too to look at the API. See the G, sorry, the G option, as we talked about, is for debugging. Um, the O is for the optimization level. So GCC is pretty smart and you could look through your code and pretty much make it smaller depending on the optimization. But sometimes you don't want that. Okay, another one is PG, which I don't know what it is. And I talked about the W option in the notes. That's for warning. Um, okay, the I is basically if you have a include directory. So if you in GCC, if you provide this option, you can pretty much provide the directory that you want GCC to look in, other than the standard directory that it looks in. And sometimes newer programmers, you have a question of, okay, where is this directory and how do I know uh, where it's looking at? Because sometimes for like, it's local to the file, and how come it's not seeing it? Or perhaps it's just a folder above, and you want to see the all the folders that it's looking at. The L flag is for basically linking, so linking a shared object or a library. Um, D, I think this is means define. So if you have a define macro, you define something, um, then when you give it the D flag, that definition will be defined, and then it should execute that preprocessor command. I'm not sure what U is. I don't know if I used it. Maybe I have, but I don't believe so. And this is what I was talking about. The F option is mainly the options um, that we give it, and then the M is mainly for machine options. So like this says, so the machine option would be like ARM64, x86, RISC, that sort of stuff. Okay, the O is just your output file. So if you want to name something, um, your program something, this is when you would do it. Um, Otherwise, GCC would just give it the default name of a.out. Okay. And so it's always good to look at the man page and also the help page. So the help page for GCC, we'll do it in the command line after we go through this. So okay, I'm just gonna stop if I see anything interesting. And actually, I think we want to maybe look for the dash U. Okay, macro, fortify source. Um, You name, cancel any previous definition of name. Oh, okay. So this is just the opposite of D. Okay, so undefined. So if you have something defined or you think there's something that's defined somewhere and you want to make sure absolutely in your build system that it's not defined, then you provided this U option. So, um, I did some build systems, Yocto, and also build root, and also just the regular makefile. Um, so that's definitely something uh, that's good to know. Otherwise, if you don't really do any build system, or most of the time the build system's already done for you, or you don't mess around with that, um, then you wouldn't know this. You just have the makefile already made. So, so let's keep going. Pthread, mthread. Okay. So we're just gonna explore this stuff. Sorry, I didn't. I should really sort of have a outline, but I like this stream to be not really planned. I mean, there's the subject, which is this, and that's it. We're not going to go to make file system, that would be a separate video, but I just like to have it like a targeted subject that we could just explore and just look into. Um, just what I did with like tmux and GDB. I probably want to do something about Vim and some features it has, because those are the basically the tools I use. So yeah, we could scroll through all this and there's, tons of them. Let me actually look at the M option. Um, so just want to show you that if you never looked at the menu for GCC, um, just so you know that it's here. Um, oh, there's still F option. Okay, here we go. So the ABI, if it's big Indian, little Indian, so ABI is basically the interface for, let's see, yeah, default depends on specific target. Yeah, so this is the binary interface, mainly if you're making your OS, or if it's a different architecture. So you have to know that the ABI that you're using. Okay. And you got little Indian, so big Indian, little Indian is pretty important. And most of this stuff, I wouldn't know offhand. You probably just have to research it and go through it if you don't understand something. So, but okay. So that's what I want to go through for the man page. And you also want to do the help, or just dash H. Let's see if we can scroll up. And so this is a nice terse information here about GCC. Um, so options, help, target help. Um, okay, so there's a bunch of help here. Version's also good. I think this might be different than just the short version of dash V, because I don't know why it keeps doing that. Sorry about that. I think the dash V is um, one of it gives you more information, but we'll see. I might be wrong about that one. Okay, dump specs, dump version, dump machine. Okay, so some cross compilers would tell you what machine it's meant to cross compile into. Sometimes the name itself is in the compiler name, so you'll have something like GNU, ARM, GCC. So I'm just making it up, but there is a naming convention for cross compiling, and you'd know that if you make a cross compiler. Can't remember what the cross compiler there's besides build root and Yocto would create for you a cross compiler if you don't already have one, but there's also a program I can't remember off the top of my head, N, maybe it starts with an N, that you can create your own cross compiler. Okay, so this is a important one right here, is print search directory. And so um, that's what you want to sometimes always do, is you want to display the search path for your compiler. So let's see, let's just, did I copy that? I don't think I did. So let's just copy that and see what happens. Okay, nothing's happening. So if I can remember it, print search dir, or is it print search dirs with the S? Okay, so there you go. Gives you all the directories that it has. It says it's user lib GCC x8486 Linux GNU 9. Okay, Linux lib GCC. So this is all the directory that it looks in. So let's actually go in there and look. User lib GCC GNU 9. Okay, so there's some shared objects in here that it looks for. So that's not the only one, the last one here is the user lib library. So let's go to that one too and look. Okay, so all these libraries that you can link to. Okay. Okay, I don't think I could go back. So let's go to CD, programming C, C exploration. Okay. C. Okay. Go back to the shell. And so mostly you could just do to quickly, if it's just a small file like this, you just do hello C, and that should produce for you the output there, the out, and that just gives you that sum. So let's look at the contents of hello C. So, okay, so that's it. Just mainly standard IO, H, and then main void. So, so one thing we want to do is give it the option C is just to make the object file. So if you do without C, that should give you the object file here. So this is that hello O. So it tells you that hello O is an elf. So sometimes it's relocatable. Sometimes you don't want that, so you provide the fpic option. But that's something that not stripped. So sometimes you want to strip it if you're in embedded programming. You want to make it even smaller depending on how much memory you have. Although most embedded system are memory is cheap and it's getting pretty big, but there are still some microcontrollers and embedded device that doesn't have uh, too much memory, so you want your programs to be really small. Okay, let's see. What else do I want to talk about? Oh yeah, let's look at compare that to the just the regular output. So A out, which is the executable one. Dynamically linked. Okay. Yeah. So it's linking to the library. So LD. So you could do a object dump and see what all it's linking. So let's see what we want. Headers, file headers, private headers, disassemble, source, full contents, debugging, bugging tabs, version, help, info. I don't know what to do. Maybe the -G or maybe A. Just do the -A. Let's see what we get. Okay. Go through the line, I guess. File headers, F. I don't know why I'm going through this file, but maybe we can talk about object dump at a later date. But as always, I like to say to always look at the help. Sometimes you can just do the short version, which I always do. Okay. What? I don't know. Okay, so that's not. That's a different help. So sometimes the short version is not the same as the long version. Okay, so that one actually did something that I didn't expect. So, okay, so for disassembler, disassembling, and so we do that with the GCC too. And also, of course, you do the man object dump. So I'm not going to go through this, but those are always my recommendation is to go through those two. That way you can see what this the tool that you have what all the features and what it could do. So I know back when I was going to university, it, you know, this when you're studying assembly language, it's good to kind of disassemble your code um, so that you sort of understand how GCC is doing that and compare it to what you're trying to do when you're programming for assembly. And there's a good website that actually um, would give you the assembly code for different architecture. Of course, this one is just for x86, and that's because our GCC is for x86. So we do -v for GCC, and let's see here what we get. Yeah, so now you know we're doing the x86 from here, um, and it tells you how it's configured. Um, so if ever you want to create um, this same GCC, you can just, when you make it, you give it to same configuration. Um, and let's see, and I believe this one is different. Let's see. Yep. So -v is has much more information, and version just pretty much gives you the version. And let's see. So print search directories, file name program, print multi-arch directory, multi-lib. Let's see if I can copy this. Some reason my Terminator terminal isn't. Okay, GCC. Is it print? I'm gonna go through some of this and then we can move on and do something else. So print multi-lib. Yeah. Okay, so 32, x32, so 32-bit compilation you could also do. And okay, so let's look at this. We have A out, GCC O. So we can also do GCC S for assembly. And then let's do low.c. Okay. Oops. Sorry. Close that out. So I guess I already have that closed. So let's look at hello S. And so here's all the assembly code. So you have the main label here. You know, push to the stack, move long address. So call, system call, leave. I don't really remember this, and return. So that's you return back to where it was before you issue that system call. And so yeah, that's okay. And so another thing that it's good for is, sometimes, here's a good one. And in Emacs, I think you have to have this feature. I'm not sure, but last time I know you could just look at all the system calls, and sometimes you could search for it. But a nice way to look at it, look at the like for instance printf that you're using, is to see where it's defined in the header. Um, so yeah, let's do that. So the dash E would give you the precompile. So if you do, let's try that, GCC dash E load.c, and usually you have to tell it where to go, because if you don't, it's just going to print to the standard out. Yeah, see, just prints to the standard out. So I think you want to give it a dash I, and that means that it's already pre-processed. But let's go back to the manual and see dash E. Okay. Dash E. Do, do, do. I'm trying to see where it says it's supposed to be dot I. Search for, okay, never mind. Okay, so let's look at hello I. So this is the preprocessor doing this. Basically, I don't actually know what all these numbers mean. If there's the line number and then 2 is like system call, and maybe it's passed that way. You know, if you guys know, you can comment below. Curious, but I haven't done this in a long time. And so here you could also look. I mean, these tells you the header, so you could see it. And so it actually brings it here. You know, all these defined. So sometimes you'll see somebody use this underscore underscore u underscore long. You know, so you could use all this. But let's look for printf. Since we use that. Okay, printf, and here we go. External printf. So there it is. And all the other printfs that you can look at. Oh, what's also good about this, anytime you see extern here, let's say you don't know what fprintf means, you know, and well, this is Vim. So in Vim, you could do Shift K, and it should take you to the man page. But if not, you know, so it tells you more about the man page, and I'm big on the manual pages. They're awesome. But if not, you could just go to the shell and type man whatever these are, and it should give you the same man page. Okay, so scan F, you could do a Shift K, and there it is. So scanf 3, so it tells you all about that. And like I said, if your editor doesn't do the navigating to the man page, you could just do it on the command line. So let's try that for scanf. So man f scanf. There you go. Same thing. So man is always good. I like to always look at this when I was new to it, to tell you what man 1, man 2, man 3, and usually you're always in this 2 to 3, sometimes 7, sometimes 1, but always the man 3 would be the most Okay, and let's see, another hint is so this apropos just looks for everything that you have for man or maybe print. Okay, so all the man pages that you can look at, the one, um, 3 is the library, 2 is the system, 1 is the shell, I think. So uname, that's the one. So man uname. Okay, print system information gives you all the information. So you can't really use it in the in your programming, but so pretty much if you see a 3, that's good. Sometimes you see something that you never seen before. It's good to look at that, see what is already in there in the library. Because sometimes, when you're learning C, they don't teach you all these other um, programs that you can link to, or shared objects, or shared library that you can link to. And you just often have to either read through a book or Google it. But this is, I think, a better option. You could always find it. You don't, it never change. So sometimes what I don't like about going online is you forget to do something, then you go online and it says like you put C how to use printf, um, and then you look through the conversation and find your answer, or you always say see how to find printf, and because of the search results, the one site that you always are looking at is maybe third in the search results, or the next page, whatever it may be. But here, if you just do man printf, it's always going to bring you here. You're always going to um, remember where it is, and then you're going to remember, am I trying to print, oh, I'm trying to print a float, so how do I print a float? And and so this would always give that to you. Um, but this one is printf1, so what you want to do is man3 printf, or if you're doing bash programming, it's the print one. So that's another good to know. If you're doing bash programming, the man one you could use, or yeah, that's the one that you should use. Man 3 would be for C programming. So yeah, here's the all the printfs, and let's see. Let's say we don't know how to do print float. Let's see if this is gonna tell us. Well, I know that's float, but let's see if it tells you. No, sometimes when you know this, you don't really go through the man pages, but just do this all the time. Okay. Okay, here we go. Conversion specifiers. So D for ints, for I, U, okay, double argument, so E, F, so there you go. And so this would never change. It's not, the site's not going to change, so the man pages don't change that much, especially for these sorts of things. So, okay. Is there anything else that I wanted to talk about before I end this? Dash. Oh, yeah. Yeah, we talked about the I here. Yeah, pretty much that's it. So I hope you learned something. Sometimes you could do this by yourself, but you're not gonna even I don't often try all the man pages and the options that you could give GCC. Um, you know, Pi, independent executable. So, oh, yeah, they're defined. Let's quickly go through that. Was it F? Okay. Um, so let's for those of you, so sometimes you do GCC define, something that you define. So say you defined hello. So and then you give it like let's see, and then say output hello. Okay. So that's fine. There's no hello, so it doesn't really matter, right? But now let's say we modify that and say that, so this is the define macro. If def hello, then else, and then let's say hello macro was defined. Okay. So now if we do this again, let's see what happens now. So see, hello macro was defined, and yeah, that happens here. So sometimes you'll see that if you're reading some programs, and it doesn't always have to be defined in the command line. You could also define it somewhere here. Define hello, and that would be sorry, be the same thing. Okay, I don't think I have a vimRC here. I keep pressing JJ to escape and it's not doing anything. Okay. So anything else? Anything else to talk about? Oh, it does work. Never mind. What am I saying? I just not pressing JJ fast enough. Okay, I think I'm going to end it there. Thanks for watching. If you have any questions or comment, I don't really look at the comments. Sorry. So yeah, thank you for watching. That's it. Bye.